All right, so we're gonna put everything together with quadratics now. So when we're looking at this is our general equation that we're gonna look at. This is everything that we've done so far, and everything's included here. The first thing that we're gonna look at is the plus or minus. Now that plus or minus just is the direction of the opening. So that's which way the parabola is facing. Whoops. If it's positive, it's going to be facing up, meaning the arrows are up. If it's negative, it's going to be facing down, the arrows are down. After that, we don't consider the negative anymore. It literally just tells us that, so don't get that confused with the A value. Okay, the A value is the stretch or the compression of the graph. Okay, that is our over and up value. Now, technically in your over and up chart, you could multiply by the negative, but if it's negative, you know it's going down, not up. The H value is our horizontal shift. And remember, when it's in the brackets, it's opposite and horizontal. Okay, whoops. When it's outside of the brackets, it's regular and vertical. So regular meaning if it says +3, you would go up 3. If it said -3, you would go down 3. Inside the brackets, if it said +3, that means we're actually going to the right. If it said to the left. If it said minus, that means you're going to the right. You're doing the opposite of what you would normally do. With all of our important values or important things about the quadratic, our vertex is always going to be HK. Our axis of symmetry is always x equals the x value of our vertex, so x equals h. If a is greater than 0, is facing up or opens up. If it's less than 0, it's facing down or opening down. Oh, I wrote opens down. The domain is always the same for every quadratic. It's from -infinity to +infinity. Now the range changes. If it's facing up, then we're going to go from K, we're including so from K to +infinity. If it's facing down, we go from -infinity up to K. Okay, and our point pattern is always going to be over and up. So over 1, 1, 1, up 1, 3, 5. But we always times that by our A value because our up values could change depending on what our A is. Okay, so if we look at these graphs, so let's graph a few of these. First, this first one. Okay, so it says state the vertex, axis of symmetry, direction of opening, max, min value. Okay, so I want you to tell us what the max or min is as well. So if I was looking at this first one, my vertex is going to be at 4, 1. Okay, my axis of symmetry then would be x equals 4. It's the x value of the vertex. The direction of opening, this is a positive graph, so it's opening up. And that means that I'm going to have a minimum value. So a min at y equals 1. It's the y value of your vertex. Okay, so if I were to graph this, I'm going to do my over and ups. So over 1, 1, 1. Actually, let's just do two of them because we only need 5 points. Up 1 and 3, but we're timesing that by 3. So it's going to be up 3 and up 9. So we're going to go starting point, over 1, up 3, over 1, up 9. So I'd be off the graph here. So I'm at 4, I'd be up to 13, which would be kind of in this neighborhood. And then same thing over here, be up here somewhere. Okay, and then we would just connect our dots. So we'd be like this and like that. Okay, the next one, I'll just change colors here so that we know what we're doing. The next one, our vertex, it's always the opposite inside. So we got -2, -4. Okay, axis of symmetry, always our x value of our vertex. Direction of opening, this time we're facing down because we have that negative. Okay, if we're facing down, that means it's a maximum. We can only get up to a certain point. So we have a max here of y equals -4. And now let's do our over and ups. So over and up, 1, 1, up. We have 1 and 3, but we're timesing that by 1/2. And we're actually timesing it by -1/2 because we're going down. Okay, so we're going down 1/2, or up -1/2, and then down 1.5. Okay, so we're gonna have -2 and -4. So there's our starting point. Now I go over 1, down 1, over 1, down 1.5. Over 1, down 1, over 1, down 1.5. And I connect my dots, put my arrow, and I'm done. Okay, I want you to try this last one. Okay, so we'll take this up tomorrow. All right, so let's look at these ones. State the domain and range of the following. Well, the first thing we need to do is recognize if it's facing up or down. This one's facing down, so that one's gonna help us. We know our domain is always the same. Our domain is always -infinity to +infinity. If it's facing down, that means that our range starts at -infinity because it's gonna go down forever and gets up to our y value of our vertex, which is always what's being added at the end, or subtracted in this case. So we have -4. Okay, if we look at this one, we're facing up in this case because we have a positive a value. So our domain is always the same, -infinity to +infinity. But our range in this case is gonna start at our k value and go up to infinity. We don't care about anything else in the graph. All we care about is which way the graph is facing and the k value. All right, if we were looking at this one, write the equation. We'll do the first two and we'll have you guys do the next one for the warm-up tomorrow. Okay, so the vertex here is write the equation given the following. So this gives us all of our values. It gives us our a, it gives us our h and our k. We just need to put it in. So we've got y equals, it always starts with our a, half. Now we have x, and then it would be minus -2. So that's x plus 2, and then plus 7. And don't forget that it's a squared graph. Now congruent is a word we need to know. So congruent means the same as, or it has the same a value. Okay, it's the same as, so it's the same shape. So if it's congruent to it, so it has the same shape. Okay, this tells us the a value. This tells us whether it's positive or negative, and here's my h and my k. So if it opens up, that means it's positive a. So we're gonna have y equals 5, because it's the same shape as -5x squared. And then we have x minus 6 squared, because we do the opposite of that, minus 1. Okay, so try this next one, and we'll take it up tomorrow. And then finally, I'll do the first one here, and you can try the second one. We've got state the transformations. So we're always going to state transformations in the order of bed mass. So multiplication first, and then adding and subtracting. So this is reflected vertically, or you could say over the x-axis. It's stretched by 6 vertically. We need to include vertically just for later when we start to do horizontal stretches. Now, it doesn't matter if you go left and right or up and down first. This is right 3 and down 4. You could say it's translated right 3 units and down 4 units. If you're just saying that it's right 3, down 4, we will get the idea. So I want you to try that last one, and again, we'll take that up tomorrow.